Hope everyone is okay. So in this session, I'm going to explain you and demonstrate you the game of life. Actually, it was introduced by John Conway. That's why it's called Conway's Game of Life. So what exactly it is, as you can see the preview here, it's a 2D cellular automation zero-player game. Okay, it's an experimental game where you just define some set of rules on individual cell. So what are those set of rules exactly? So the first rule is that they have to check the neighbors. If two or fewer neighbors are there, so it will, the current cell will die itself because of underpopulation. Same goes for this. If two or three any cell will live, any cell will live, any live cell with two or three live neighbors lives on to the next generation. I mean, it will survive. Okay, same for the third. If it's more than three, okay, like above and three, four and above, four and above, it will die because of overpopulation. This was for underpopulation. This was for overpopulation. If it's two or three exactly, it will stay alive. If it's exactly three, it will repopulate. Okay, so these are the four set of rules. So we are going first. How are we going to implement this? First, I have set some instructions. First we will set the structure of the code. Then we will create a blank canvas. Then we will create a component for the cell. And then after that, I will create a cell and a grid system for the canvas, where it will look something like this. And last but not least, we will calculate and render so that we can show the evolution and the population incline and decline throughout the duration. So without first wasting further any time, let's jump into the code. So let's start the code. First thing first, I will set initial function that will run instantly when we are running the code. Okay, secondly, I will create just a second. Yeah, I will create an object area that will work with canvas. Create element, I will say canvas. Okay, then what I'll do, this area will have a function called start, which will be triggered on init function. What it will do, it will create canvas dimensions with, and in this case, since we will demonstrate it on the entire browser area, so I'm going to set the dimension of the canvas exactly to the dimension of the browser window. So windows dot width, inner width, and this dot canvas dot height is equal to windows dot inner height. Okay, and then I'm going to apply this canvas to the body and insert before, I'll say before, insert before this dot canvas and document dot body dot inner child node, which is supposed to be 0 because we don't have any node on the body. And then I will set the context dot ctx is equal to this dot canvas dot get context, which in that case we are working with 2D, so that's 2D. Then yeah, that's pretty much for now. And when we will set this area dot start, as soon as we will do this, we will check it on the inspect element. We have our blank canvas, as you can see. So now what I have to do in the next step is I have to set this blank canvas to black, because as we have noticed that this entire structure, this entire canvas is black. So for that, I'll go back to the code, and we already have the context, so we will create another function, this dot set background, and this is a function, and in that I will set this dot fill, this dot canvas, this dot ctx dot fill style is equal to black, and this dot ctx dot fill rec, that is the function that is responsible for creating rectangle. And this canvas dot width, I have to set the dimension, position and dimension, so this dot canvas dot height. Okay, so here goes how to do this, and we will set it to okay, so this dot set background. Okay, so here we have our black background. So now what was our next step? We go back, so we will create a cell component. Okay, so for that I'll go back to the code and I'll create another class called cell, and which will take width, height, x-axis, y-axis, and color. Okay, so this, or maybe just a second, this dot this width, height, x axis, y axis, and for the color we will set color, or if not, in case it's by default black. Okay, and we have to add two new properties because each cell, as you have seen, to determine or if the cell is dead or alive, we have to maintain the set. In this case, I'm going to set state as by default 0. This means that whenever the cell is created, it's by default dead. Okay, so in that we will have another function that will be called render. This function will be responsible to display the cell ctx. We will get the context, and in the context ctx dot fill style is equal to this dot state. If state is equal to 1, then this dot color, else black. Okay, oh, that's then rectangle fill rectangle, again this dot x, this dot y. Okay, I forgot to do one thing, because I forgot to increase. Much better. At least you guys are able to see a bit now. I don't think I need this, so but I'll keep it. Okay, much better. So where were we here? So there's this, and the width. Okay, yeah, this dot width and this dot height. Okay, and yeah. So we have our cell component ready. One more thing. We will set the background as well to white, so that when we place the cell, we can see the grid. Okay, we can see the grid, because I'll explain you in a moment. Okay, white ctx dot line width is equal to 0.110, ctx dot stroke rec, this dot x, this dot y, this dot width, and this dot height. Okay, so we have set the filling of the rectangle, which is black, and the boundaries or the borders or the stroke, line stroke, to be white. Okay, so we have our cell structure, cell class ready. This cell will have some basic properties like the nature and the position of the dimension and the position of the cell. Okay, the color of the cell and the state of the cell. Okay, if it is 1, if it's 0 for dead, 1 for alive. Okay, so yeah, that's fourth point. Okay, so the third point is also complete. We have created the cell structure class component, cell class component. So now we're going to implement the cell, and this cell will help us integrate to build the grid system. Okay, coming back to this and this code. So now we're going to implement grid. So for that, what we are going to do is we're going to add another function here. It says set grid. So this will be the for loop, okay, with y, and the array okay, for that first I have to set the default dimension of the cell. So in that case we will set it by default to 10. Okay, you can set it anywhere. I'll explain you why I did this. So where were we? So this is the basic typical for loop. So what I'm going to do is how I'm going to exactly form a grid. So let's suppose, for example, you can see that, okay, let's suppose, for example, we have, okay, it's a rough sketch, so hope you don't mind, guys. So let's suppose this is a browser screen. So in that we have a dimension, so we have a height and we have a width. So what I'm going to do is, instead I'm going to calculate everything and then set bars and the rows like a table, HTML table. I'm not going to do that. Instead I'm going to just place cell one after the other till it reaches to the end of the screen, to the edge, because since all the cells have the same dimensions, so it will give an illusion of a grid. I'm not going to draw entirely, but you got the idea. Okay, so in case of row and column, this is what I'm going to do. So coming back to the code, yeah, so where were we? So I will set the how long this for loop will go based on the dimension, as I said, of the the canvas, the dimension of the canvas, and I will skip the loop to the, basically I'll try to end this loop to the edge of the canvas in terms of height, right now in case of height. And let's suppose, again coming back to the, but we got the idea. Okay, so this dot canvas dot, not sorry, this dot cell dim. Okay, so again I'm going to create, let cell raw is equal to new array, and that I will create another loop saying x, and this time is will be this dot canvas dot width and this dot cell dim. Okay, so const cell is equal to new cell, and this dot cell dim, x-axis and y-axis, and by default it will be white, and the color will be white, not by default, and the state is 1. And I will do the render of the cell, and then I will add this cell into the cell raw. We now have the raw which contains each cell, and this entire raw will be saved into the column cell, which is new array this dot cells dot push dot cell raw. Okay, so we will implement this function set grid. Okay, so we have cells, that's in the cell. We go back, and if I refresh it, voila, you can see the grid now. Okay, it's crystal clear, it's very symmetric, and it's very aligned, even though they are not, this is not a grid, these are each individual cells. If I change the dimension of the cell to a bit bigger, you will see that these are cells placed after one another in row and column, but it gives an illusion of a grid. So let's suppose if I set one cell to update the state of one cell of let to alive. Okay, let's see what happens. For just a second, for that I will set in the center. Okay, let's check if it works. H mid is equal to area dot cells dot length divided by 2. Okay, and cell dot 0 and width. Okay, and then do the math dot round, and for that as well. And then what I'm going to do, I'm going to create a cell is equal to area dot cells. Let's suppose select the cell h height and cell h mid. Okay, and cell dot state is equal to set it to 1, and cell dot render. Let's see what happens. Voila! As you can see that it shows a state to be alive in the center, so it's pretty good. So we are very close to our point. So now what we're going to do is we're going to calculate and render. So for that, let's suppose how am I going to do this? For that, let's suppose we have a grid, and in that we have a cell that is alive in the middle. So according to the 4 rules, I have to check this. I have to check all the surroundings. Okay. So again, if it's 0 or 1, it will die if it is because of underpopulation. If it is 4 or greater than 4, it will die of overpopulation. If it is 2 or 3, it will remain the same. Okay, if it is exactly the 3, and if it is unalive, it will alive itself, it will repopulate it. So we're going to implement this rule as quickly as possible. So we're going back and do this, and then calculate cells. Okay, this will be the function, and let height is equal to this dot cells dot length, let width is equal to this dot cells 0 dot length. So we have height and width. We will add for loop, okay, with y and height. Okay, and we'll create another for loop which is x, and that's just for width. This is for width. Here I'm going to check the numbers of neighbors. Okay, this is how I'm going to implement. I'm going to count how many neighbors are alive, and then we will then I will do the operation if I want to set the current cell to be alive or unalive. So const current cell is equal to this dot cells y and x, and I will then calculate it. I mean, I can manually select each index and write bunch of statements, but it is for me it is quite untidy and unprofessional. So what I'm going to do, I'm going to loop through the entire grid and exclude this one. Okay, I will count 1 from the top left, top mid, top right, mid left, ignore this, mid right, okay, bottom left, bottom mid, bottom right. Okay, this is how I'm going to iterate it. How I'm going to iterate it? For that, I'm going to use the for loop again. This time I will set ny, neighbor y, and I will set the initial point to be y minus 1 because I need to check the back side, okay, from the previous, from the negative to positive, one step back, one step positive. So for that I'm going to check one step back till the one step positive, y plus 1, okay, and then I will do another for loop, this time nx, same with the x minus 1 and n minus plus 1. I will get the neighbor constant n cell, neighbor cell, this dot cells, okay. I will check ny and nx. I will calculate the state of the cell and cell dot state, and I will confirm as well if I'm excluding the current from the calculation. So ny is equal to nx. Don't do the calculation in case if I'm on current, okay. I can do the edge cases. I can wrap the edge cases, but I'm too lazy for that, so I'm going to just use try catch. So please don't kill me. I mean, I know this is very illegal to do, but because of shortage of time, I'm just passing the try catch to handle the edge cases. What are edge cases? In case if the loop starts to iterate from the beginning, so there's no minus in that. Like the cell is already on the position 0 in x-axis and 0 in y-axis, so we cannot go in minus x, okay, minus 1 or minus y in both cases. So it will give you an error, index out of 1 error. So better to handle the try catch. Once it is done, so it's yeah, once it is done, then we will check. Okay, before that I forgot to mention one thing, that the rule is to calculate all in the one generation. Let's suppose if we are in the first generation, we will first calculate entire canvas, all the cells, without changing the state, and once we have the result, we will apply, and then we will move to next generation. Let's suppose, for example, how do I explain this? Let's suppose we have a grid, okay. We have cell here, we have cell here, we have cell here, here, and here, and here. Okay, so during this calculation, okay, one by one the system goes to each cell and check its neighbor. So we are not going to instantly change the state of the current cell, okay. We are going to keep those states in check, and then once the entire calculation is done in the one generation, then we will apply it, and then we will repeat the cycle, okay. So for that I have to create another state in the cell as a new state, this dot new state, which is by default 0, and what it will do, it will check and update the new state instead of the current state, the real state. So what it will do, first I will check if neighbors is below 2 or above, equal to or above 4, okay. I'll say that's current cell dot new state should be unalive, else if neighbors is equal to 3. See, I excluded the condition 2 true because it says that whatever in case of 2, if we go back, any cell, alive cell with 2 or 3, okay, yeah, any cell which is 2 or 3 will alive, okay, we'll move on to the next generation, 2 or 3, and in this condition it says that if it's 3, okay, if in case of the cell is not alive, it will make it alive. So in that case, if you notice that I don't need to put explicitly the condition 2, because in the condition 2 it will status quo. Like for example, in the condition 2, let's suppose if I can put the condition 2 in that case, just for a second, what I can do, this, okay, so whatever the state was already there in the cell, I will update it. So I don't need to do that, I just exclude it. Okay, so once the new state is updated, we will then update and render it. So for that, again, y height for x width, okay, so constant current state, I'll just copy it from here, and I'll copy it from here, no copy current dot state is equal to current dot new state, and then current dot render, yeah, fine, okay, and then we'll set this function on the set time interval so that it will work as a time, like a little time. In this case I will set it to width, and the time area dot this, and the time will be 100. Let's check. Okay, I'm getting error. What is the error? Oh, x. So as you can see that the cell vanished because technically there was no neighbor, so it unalived itself. So for that we have to create some good amount of predefined cell. So no problem. First thing first, I will what I can do here is I can first add a random function that returns from the range. I copied it from the Google. Then what I can do is I can iterate this entire thing to a certain dimension, range of dimension. Let's suppose in that case I'll do it 100. Okay, so 100, and I will set let our const cell h is equal to random integer. Let's suppose from -10 to -10 plus 10, and same applies for just range. Let's suppose just no better. Do this, and then let cell is equal to area dot cell h is equal to cell w. Okay, cell dot state is equal to 1, and then cell dot render. Okay, let's see. Okay, I missed something. What did I miss? Cell with net, cell with height. Oh, okay, sorry, my bad. I didn't use this because technically this is from the range of -to 10. So in index there is no minus. So yeah, sorry, my bad. What I wanted to do is from the midpoint of the entire screen, -10 and +10. -10, sorry, +10, -10. So within that range. Without this variable, I was just trying to render it outside the canvas, which is not possible. So yeah, here we go. We have, but we're still getting error. What is the error? What is 30? Okay, if I reduce the size to back to 10. So as you can see, okay, if I refresh, so as you can see, our game of life has taken into shape. So as you can see that it's keep evolving, and in the end I've observed a bit, most of the time it comes to a bit stable position where you can see blinkers. If I go down and show you some patterns, we have blinkers, still files, that's called still files. We have oscillators, we have spaceships. So in the still file we have still life, we have block, beehive, loaf, boat, and so on and so forth. So you can observe this patterns here as well. You can see that there's a blinker, here's a blinker, here's a loaf, there's a, I don't know what is that, it was a beehive, it's a block, it's a pulsar. So you got the idea. We can also make it a bit better if I set it to black and set the yeah, that looks better. Yep, it looks better. So it's pretty neat. It looks beautiful. You can see that there's a glider. If I refresh, so as you can see, if I refresh my canvas, you can see that if I refresh, you can see a cell being populated in a certain region of the center because of randomness that I put into the beginning. So once I let the refresh button go, you can see that the population is evolving. You can see some patterns like blinker, glider, block, and pulsar. It's evolving. Okay, either it will die or it will keep going on like this. But in most cases, if I've observed, they come to the stability where neither they populate or they die. They just stay like this, like for this blocker or blinker or boat or leaf. So yeah, that's it for today. Thank you for watching, and please leave some feedback if I can improve my content, or if you have any idea that you can share that I can demonstrate in my next session. That would be great. So overall, thanks for watching. See you.